Welcome to Module 5. Most data tutorials end with a dashboard, a couple of pie charts, and a data table. But in the real world, read-only dashboards are dead weight. If a commander sees a problem on a screen, but has to open 3 different apps or send an email to actually fix it, the operational loop is broken. That gap between insight and execution is where organizations lose millions of dollars or lose missions. Today, we aren't building a dashboard. We are building a closed-loop command and control system. We're going to wire 4 principles: application state, agentic AI, write-back actions, and graph traversal. So let's deploy. To start, you'd navigate to your applications folder. Here you'd click New and select Foundry's Workshop module to get a blank canvas. But off camera, I laid out our visual skeleton and wired the underlying logic, so let's look at the engine. In legacy systems, users typically suffer from context switching. So you look at a list in one window and query details in another. We solve this using variables to manage application state. So on our mission list, if we look at the configuration panel, I've created a selection variable called active mission. This acts as the short-term memory of the app. It tells Foundry whatever row the user clicks, memorize it. Then I go to the dossier on the right and set its input data to that exact same active mission variable. Now the UI is dynamically linked. There's zero context switching, which means perfect situational awareness. So let's dive into Agentic AI. You see, I need to deploy a soldier, but manually checking like hundreds of personnel files is a human bottleneck. So we jump into the AIP Logic to build an autonomous intelligence officer. First, we have to define the input here. And we tell the AI to expect a single mission object to be passed into it. Now, this isn't a basic chatbot guessing answers. We put the large language model into a chain of thought reasoning mode, and we handed a governed tool, Query Ontology. This gives the AI a secure read-only connection to our database. Now, instead of hallucinating, the AI constructs structured database queries. It reads the mission skills, queries our active roster, and returns a tactical brief. We just reduced analysis time from hours to seconds. Now on write back. Let's quickly pause here, because this is where a lot of systems fail. We have the AI's recommendation from what we set up in AIP, but how do we execute? If the user has to send an email or manually update a spreadsheet, the operational loop is broken. So we use Ontology actions. And, well, let me just quickly clear that up. Palantir databases are sort of strictly locked down by default on the back end. We built a permissioned rule, and I'll show you that. You take the operative ID from the user selection and securely paste it into the mission's assigned slot. This guarantees data integrity and creates a perfect audit trail. Back in Workshop, I wired our AI and our action to these buttons. I pass them our active mission variable, so the user never has to manually type an ID. And yeah, we should probably test the operational loop. Before that, just showing you on the right side how things have been configured. So how this works is that I click a mission, I hit recommend agent, and while I wait, I'm going to speed up the video, and the AI brief generates. And from that point on, we will agree with the choice. Oh, pretty quick. So, I guess our top candidate here is Tempest Ocelot. And that's kind of who I want to assign to this. So herein, let's say I agree with the choice. And I want to deploy him or her to this mission. So herein, we'll bring up Tempest Ocelot. And that's our operative. We'll hit submit. The database will update with that operative's assigned ID. And this will update globally in real time. And that loop is closed. Now let's talk about graph traversal. We have a leak. On our internal affairs tab, I built a chart filtered to failed missions, grouped by the authorizing officer. Flat spreadsheets hide anomalies. The Ontology visually exposes them. So look at this officer. Mr. 44 has a huge, massive failure rate. So how do we catch them? So when we go to our variables menu, herein, I sort of tell the variable to listen to the chart. When I click a bar, it takes those failed missions and traverses the Ontology link straight to the commander who ordered them. Relational graph traversal. 0 code. See, I wired the profile card to that variable. But for the kill switch, I told the action parameter, don't ask for user input. Just grab the exact operative that is currently rendered on the screen above you. And this eliminates human error. So let's pull the trigger. Not this guy. Not Viper Bear. Frost Tiger. See, I click the anomaly and the app follows the graph. And the rogue commander's profile loads instantly. So I build one final action here. The kill switch. In the real corporate world, you wouldn't revoke a commander's security clearance just because a chart looks bad. You trigger an automated investigation workflow, but this is Outer Heaven, and today I'm playing God. So I hit revoke clearance, and it executes a pre-authorized write back, bypassing the confirmation form, and via Frost Tiger, not Viper Bear, Frost Tiger status instantly changed to revoke. So she's locked out of the system instantly, and the risk is mitigated. So, something important that I forgot. If you show a one-click kill switch to a CEO or a compliance officer, they're going to panic, and they will ask, who watches the watcher? And how do we prevent abuse? So, because I forgot to build this, I need to build it now. A quick little audit trail. So we're going to add a widget right below it. The edit history, and we're going to set the operative view. Okay, cool, it works. But it's not really bringing up any edits because we just built this widget. I'm going to speed this up. But look at that. It works. We now have a clear audit trail. So the system, which is permanently records that I, the logged in user, changed her status to detained at this exact second. So that's total operational speed backed by absolute accountability. And yeah, every ontology action automatically pretty much generates an immutable event log. Variables for state, agentic AI for reasoning, ontology actions for execution, graph traversal for anomaly detection. By stacking these foundational mechanisms, we didn't just visualize data. We built a tactical system that accelerates decisions, removes human bottlenecks, and closes the gap between insight and execution. In our final video after this, we'll do a quick mission debrief and provide a recap. Till next time.